Okay, January 18th, we'll get started with Notebook 9, Introduction to the Pandas Library. Share my screen, my whole screen, nothing but the screen. So help me. Okay. And again, give credit where credit is due. Give a shout out to my colleague, Mike Ellis at UCA. These notebooks continue to be useful. So pandas, talking about libraries. And again, a library in Python is kind of like a library in a book. Um, you can't. I mean, a kind of like a library has books in it, so that you don't have to keep all of that knowledge in your head. Well, if you put all the functionality that has been written for Python, written and available and put out there in the Python coding universe, it would probably swamp the best workstation. So to make things more modular, where updates are only done within areas of the code where they're needed, and so you don't have to update everything just when one little chunk of code in pandas or in some other operating system library. Um, um, you only have to refresh that library in your environment. You don't have to refresh the entire Python. So it's all for modularity and resource utilization on your computer. Pandas is arguably one of the reasons Python is gaining in popularity. I want to say, I don't know for how long, but the R programming language that a lot of hardcore scientists use, um, the data frame is built in. This Excel worksheet looking structure that you can use is built in, but in Python, it's a very useful add-on library. Um, and it's out there. I can't remember. I've looked it up 2 or 3 times and forgotten it, but there's a reason the author named it pandas. Um, I it had something to do with Python data structure or something. It's not necessarily the bear, but it's out there on the web if you want to go look that up. Um, so the main there are two main structures in pandas that we will deal with, the series and the data frame. And a series is really just a column, and a data frame is really just a worksheet, or as far as what it looks like and kind of how to think about it and operate on it. So a data frame is made up of one or more series of data. Um, so yeah, why use a library? There it talks about just you would swamp it. So there's this thing out there in the Python universe called minimally sufficient pandas, and it's really just this is from the original author of the library and the Pandas for Everyone textbook, which I've got a copy of. I'll post that to the classroom. It's really just, once you learn one way to do something, that's okay. Um, but really shoot for straightforward, simple, elegant programming, and you'll be okay. And here's a link for more information on that. So the Pandas library, if you just install Python, just base Python on your system, you don't do the Anaconda's distribution thing like we did. If you just have Python, you have to install the Pandas library on your computer. But because we did uh, the Anaconda distribution, it and about, I don't know, 60 other libraries come with it. So we don't have to do any sort of installing. It's already the software, the package is already on your hard drive. So all you have to do is import it into your Jupyter notebook in order to use it. So that's what we got in cell 1. So let me pull up my participants thing here. Everybody execute that first cell where it says import as PD. It's not going to do anything, but you should get a 1 uh, like I just did. The first time you do it, it might take a few more seconds than that. But once you get that 1 back and you don't get any kind of error or anything like that, give me a thumbs up in the reactions.
I'm sorry, what is it that we're supposed to see? I don't know if maybe mine's just not working when I press run.
You're just supposed to see a 1 in that square bracket next to, do you see my notebook?
Oh, yes. Okay. Mine has a 2. Is that okay?
Yeah. If you ran
Okay.
it twice or whatever, that's just, remember, that's just the order of execution of the cell. I, I'm not seeing thumbs ups in the participants view. I'm trying to remember. If you start your camera, you start to see those over in the camera view. But yeah, everybody looking good, looks like. So I'm going to say then, looks like it's all working. If you are having problems, give me a shout. Slow me down. So that's the first thing you do in any notebook where you're going to be using a library functionality. You remember you got to import the library, or it won't understand what you're trying to do. So um, you see here that this line is import pandas as PD. You can alias a library. Some of them have pretty lengthy names, and the way you refer to functionality within the library is with dot notation. So if you want to call a function in the pandas library, you have to say PD dot whatever and then function name. Um, just like you get to methods in the string class. You say the variable name dot truncate or whatever the function is that you're working with. Same with libraries. So if you want to use a function within the pandas library, you use this PD now because we've aliased the pandas library as PD, and that is, you see that all over the web. That's just the convention. So it makes it a little less typing. And another convention that you see is when you're just working generically with a data frame, which again is that rectangular um, data structure. You you see the convention DF for data frame. So execute this second cell, which will use the read CSV, which is comma separated value. PD.readCSV is a method. I'm sorry, a function inside of the pandas library, which will convert a CSV file into something with headers and a row number, so that you can start to work with it kind of like a spreadsheet. So everybody execute that, and you're not printing it or anything. You're not doing anything with it yet. So all you should get is the next number in the sequence in your little bracket next to the cell here on the left side of the cell. Okay, so read CSV. Of course, everything in Python has documentation. PD calls the pandas library. Dot Read CSV is how you get the dot is how you get to things inside the pandas library. The read CSV is a function, and then this R Applewood CSV part, the R in front of a string literal when you're opening up a file, and we covered this the very last Python lesson back in December, um, uh, causes these backslashes to be read correctly, like you would want them to as directories or as folders, because just generically, that's kind of like an escape special character weirdness with Python. So R means no, just use them. Don't use them as an escape character. Use it as what it is, a slash and a directory name. So whenever you see me dealing with files, whether it's in pandas or just normal text files or anything like that, in any of these notebooks, you'll usually see that designation. And remember, dot dot goes up one level because we're currently in my folders. But if I go up one level and then back down into data, because data is at the same level as my notebooks folder. So that's what that does. And we opened up a file called Applewood 2011 CSV. And another cool thing I'll show you real quick here is when you're in this Pandas Explorer or this Anaconda Explorer, you don't Jupyter Explorer, you don't have to go back out to the operating system if you want to check out a text file. You can go up one. See, I'm in notebooks. I'm going to go up one by clicking on Python and then down into my data directory. And then these files aren't notebooks, so it won't bring up Python, but it'll view a CSV file or a text file, so you can at least see what's in it. So real quickly, if we look inside of Applewood, we see your absolutely quintessential structure for a comma separated values file, which is to have header data in the first row. So we've got one age, profit, location, vehicle type, and previous. So we've got 5 headers. And of course, if you look down, you've got 5 data fields separated by commas. Your absolutely typical comma separated value file. And now, because this is not a Jupyter notebook, there is no close and halt. You just kill this tab to put it away. Okay, so we have opened that as a data frame called DF, an object of class pandas data frame, and the variable is now called DF, and you can do a lot of things with it, kind of like you would do with you can print it, you can do some things with it like you can other objects, other more simple objects, but this is where it starts to get pretty complex. So, dude, where's my data? The DF variable stores this thing, data frame. Again, it's a two-dimensional table, just like a Excel worksheet or the results of a SQL query or a table in a relational database. And that's Notebook 10 is actually pulling data out of MariaDB into a data frame. So each row in the data frame has an index, just like a list of values has an index. So for a data frame, it's kind of like a primary key for the table. As you'll see here, by default, it uses just a generic number, but you can assign one of the columns as the index so that it makes more sense. Like if you pulled everything out of a table in a relational database, it would into a data frame, it would the data frame would have a 0 through whatever numeric index, but you can tell pandas to use one of your columns, whichever your primary key field is in the database, you can tell it to use that that column as your index for the data frame. So it's more meaningful when you go looking through the data. And that's what we're saying here in this next one. If there isn't an index, pandas will create one. And by default, yeah, it's just a number. So there's lots of methods built into a data frame. Lots of things where you just say, we created ours called df. There's a whole lot of functionality out there that you access by just saying df dot and then the method name, and it will execute that functionality on this data frame. And you can have, 1, 2, 5, 10, 30 data frames open in any one Python program, each one of them, usable like a table. Okay. So we want to see what our data looks like. Okay. And some of you have probably gotten tired of me talking and skipped. Who skipped forward and executed the next code cell? Be honest. None? You're all waiting for me? Wow. You guys are great. So here are some methods, some data frame methods that let you just look at your data. Now, just like everything else, you can type in the name, or just put the name of a variable in one of your code cells, and if you just put the variable, it puts the value of that variable out to standard output, out to the screen. But remember, if you just do that, each one will overwrite the previous one. So really, only the last time you do that in a cell will be displayed. So I try to never, ever do that. So you can use the print method in addition to a lot of these things. But when I'm working with a data frame, I've kind of learned it where I will avoid the print statement and just type in the variable and the method. And here are a couple of really common ones. If you just want to see what your data frame looks like and you don't want to go back out and look at the actual data file, you can look at it quickly and easily as in its life as a data frame by typing df.head, and then you're not passing any parameters, but you still need the open paren, close paren. And df.head by default looks at the first 5 rows. df.tail looks at the last 5 rows. The head of the data frame, the tail of the data frame. Columns gives you the names of the columns. Info really gives you more about the entire data frame itself without showing you the data inside of the column. Describe gives you some basic statistics. So here we'll get down to we're printing. I added the type of the data frame columns method, and then I just say df.tail, which is the last 5 rows. So I wanted to show that this you're starting to see when you look at the type, the data type, you're starting to see that these are types declared within the pandas library. Pandas.core is pretty much what everything is, and the list of columns is an index. The columns can be used kind of like an index, and the rows here can be used kind of like an index. And since tail gives you the last 5, we can see that we've got 175 through 179, index number 175 through 179. Remember, in this next code cell, df.head calls the head method, and it will by default give you 5 rows. But if you want more than that, you can pass the first parameters, how many rows you want to display. So if we hit return on that, we start to see what the data frame looks like, the first 10 rows. And again, just like everything else in Python, the default index that the read CSV function puts on the data frame is just a numeric index from 0 to the end of data. So that's what you're seeing out here on the left is this automatic index for this row that pandas assigns, and then the columns match exactly what's in the CSV. The first header was aged, and so on and so forth. Okay, so that's how you look at your data frame real quickly, and you'll see that in a lot of tutorials and a lot of notebooks that are out there. Um, you open up a data file, you do a df.head just to look at what columns you've got and what is inside the data. Okay, and then info just tells you about the overall data frame. So we've got 180 entries. So we've got 180 rows of data um, indexed from 0 to 179. Remember, the column names aren't included as a row, even though it's a row in your data file in your CSV. It defaults to using that first row. By default, it uses that first row as your column name. So df.info will tell you that you've got 180 rows of data split into 5 columns, and then it tells you this is the index number of the column, and we'll see that here in a little bit, where you can refer to columns either by their column name or by their position, which comes in handy. I did a project with the newspaper folks, and I looped across the top, across the columns by number, not by name, not by column name, but by the position of the column, because we had, I don't know, 50 or 60 columns that were all basically the same thing, just a different kind of a different type, a different date, different type of date, I believe. Um, so you can refer to the column by its name or by its position. And again, column 1 is column 0. Index number 0 is the first column, and it goes across in numeric order like that. And then it gives you a snapshot of null values, which can be really handy. Null values will interfere with a lot of algorithms and analysis. And then it tells you the assigned data type of that column. Remember, a data frame is made up of one or more series, pandas series, and a series is just a column of data. And a series is one data type. It's not like a list. It's not like a base Python list or tuple where you can have, integers and floats and strings all living happily together in the same list. A Python data frame is more like an Excel column where the whole column is a data type, which makes sense if you think about it. So when we read this stuff in, and I want to say these are pandas data types, not base data types, or they're NumPy data types. There's a library that pandas is based on called NumPy. But anyway, this is what's been assigned as the value. So numerics are integer, and strings they're calling an object. It doesn't necessarily call that a base str. But I'm getting into the weeds a little bit too much. And then df.describe goes into that very same data frame and pulls up summary statistics that can be very useful. So we're getting into descriptive statistics of an entire worksheet. at in one short command. Think of how you would get descriptive summary to statistics that look like this uh, in Excel. You know, if you've got the data analysis tool pack loaded, and you can do it in 3 or 4 mouse clicks. But there are people that do this sort of analysis uh, using these programming languages because they've got the syntax memorized, um, and it works. So yeah, so there's described. So uh, again, we've got the number, the arithmetic mean, the standard deviation, um, the minimum, the 25th quartile, the median is the 50%. It goes through. So what? There's 180 observations here, so it goes up to number 90, and tells you what the value is. So the median of age is 46. 75th, so three-fourths quartile, 75th quartile. And then the maximum. So we've got inside of this data file, we got ages from 21 to 73. And of course, the range is just the max minus the min. But it does that for every describe provides descriptive statistics for all numeric columns. And I want to say, oh, pardon me, I'm getting dried out. Seems like the Python, I mean the Excel data analysis tool pack does the same thing, because you can't do descriptive statistics of strings. It's kind of like apples and ooples and bananas. If you watch the Barney cartoon, it's apples and bananas. It's yeah, can't do descriptive stats of what could be a categorical variable, really. So that's how you look at a data frame. I mean, it's bam, one line of code, and you start to see what's going on inside that data frame. But I did want to take just a minute for a philosophical aside. To me, because I don't work with Python all day, every day, what really makes it useful, um, more than Excel or more than maybe a Power BI or a Tableau, is that once you get a piece of code working, it works, quickly. uh, every time it automates the same steps, the same procedures, um, and it does that very well. I don't know that I would ever stop using Excel just because I got better at Python. But if I were going to automate opening up, a monthly data dump from some system and run a report or create a report, uh, once I got it working interactively in a Jupyter notebook, you could easily take that software, take that code, and put it in a Python script file, which can be executed, by the computer itself. You don't even need a human involved. And it would do the same thing. And I think Jeremy told me for the CAE folks that he's doing some data engineering in Python. So he's pulling stuff out, manipulating it, doing the wrangling in Python, and then saving the result so that it can be used by Domo or Excel or whatever like that. I know there's at least one bank that I work with. They do all of their data engineering in Python. So they grab data out of underlying support systems, out of underlying databases. They pull it into Python, into Pandas data frames, and then slice, dice, transform, do all the stuff that they're going to do. And then once the data frame looks like what you want it to, it writes it out either saves it to a file, or you can write to the database from Python, and it does that every time, without supervision. It does it perfectly. If you get it working, it works every time. And that's the main strength to me of learning a scripting language is to automate repetitive processes like that more than this interactive method. Even though this is useful, to me, that's the real magic of learning a scripting language, is automating processes. So, philosophical rant aside, I think that was 4 minutes. Okay, so again, pandas has two main data structures that we're dealing with: the series and the data frame. You can create a series, which is a lot like a list, but not exactly. You can create a series standalone, and there's a few advantages of a Python series versus like a NumPy array or a base Python list or tuple. But generally, you're going to be working with series as columns in a data frame. So, yep, a pandas data frame is a rectangular data set. You just saw one, looks like a table, columns and rows. Um, uh, each column can be a different data type, but within a column, the data type pertains to the whole, applies to the whole column. A panda series is just a column of data, and data frames are composed of series. So, yeah, a series will have a data type, as opposed to a list where each individual element in the list has a. So we're just gonna 1102. Yeah, we're just gonna talk about the series briefly here. They come in handy. You see them used. It's like a smart list, a smart list of values. So you start with a list, as we do here. Is this the line? Have I missed executing anything? No. Okay, so we start here by declaring a list, just like we did in the lists and tuples notebook. So we create a list of values here and we print it out just like any other Python list. But then we use a pandas PD dot, a pandas function, just like read CSV, right? Was a function inside the pandas library. We're going to use a function called series, which is just like when we call list or tuple or int or float or stir. It's a conversion function of whatever you send it. So you send the input parameter to the series function is a Python list, which we created here just before, and you assign it to something else. Now, data will be a pandas series, and you'll see here that pandas is built on NumPy, and when you look at these libraries, there's libraries import other libraries, and they do the importing for you, so you don't have to. You don't have to worry about importing NumPy, but Pandas does that out when you import it into your code. It imports the libraries that it needs for its underlying functionality, and it's at least a dozen inside the Pandas source code. So we're going to create a pandas series called data by converting a base Python list into a pandas series. And then we're going to print data and see what that looks like compared to just printing my list. And then I put a blank line in there just for grins. And then we're going to show the data type of the first element inside of that pandas series. which you'll see is a NumPy float. So these series don't use base Python data types. They use NumPy data types, which are closely related, but not exactly. Okay. 9 more minutes. Any questions on that? Is that coming through pretty clear? Making sense, at least cerebrally?
Yeah.
So yeah, the value 2.25 in the first, call it the first cell, the first element of that series we just created is a NumPy data type. And that starts to show you with a kind of the embedded nesting of these libraries. It just yeah, it's a whole gigantic, enormous ecosystem of Python stuff. So by default, because we didn't tell it any other way to index the series, Python or Pandas puts in a numeric index, just like a list. So now that we have a series, there are methods that we can call, and one of them here is the values method, and that will print the first or I'm sorry, the second, actually the second value in the so we can use the numeric index, but we can also declare an index, which is what we're going to do in the next one. But now that I'm looking at this, I'm thinking, why are we not just saying print data and then just the square bracket? So hang on, let me get rid of dot values and see if that doesn't do the exact same thing. It does. So yeah, dot values. Not really sure why we need a dot values method when you can just use the numeric index. Maybe we'll get to that, and it'll remind me why we need a values. But looking at that, I just didn't seem right. Oop. I need to put that back in or I'll forget. So there's a dot values and dot index attributes of a series. Again, we don't work with series all that much by themselves, but each column is a series, so we kind of need to know how that works, because you will be working with individual columns. So anyway, this next one changes. We're going to use the same variable name data, but since we're in an assignment statement, it's going to assign a new value to it. So this time we're calling the pandas series function, but instead of just sending it a list as the first parameter, which is the minimum thing you have to do is pass it a list, you can also send it an optional parameter called index equals, and that lets you give a more meaningful index than this 0, 1, 2, 3, 4. So we're creating a 4 element series, and now we're able to index it using A, B, C, or D. So now, instead of, remember before we had 0, 1, 2, 3, and 0, 1, 2, and 3 as our default automatic indexing scheme. Now Pandas has assigned A, B, C, and D because we told it make the index for 2.25 A, make for 2.5 make it B. They don't have to be in order this way, but you would line it out that way. Anyway, that's how you create an index. And now, because our index is a string, we put it in quotes, and we say we're printing data cell C, which is the third one, which is 2.75, and bang, there's our 2.75 right there. And depending on how your data works out, your index is kind of like a primary key in a table, right? So those are definitely not always nice, neat, sequential things. So this next cell uses the data again. So we're going to assign data the value of a panda series. Same values, but we're creating different indexes here. And now they're numeric, but they're not sequential, and they're certainly not the 0, 1, 2, and 3 like before. And that just shows you that when we print data index 1492, it's going to get the third cell just like C did before. But again, because it's numeric, we don't use quotes now. And those uh, little nuances can cause you some errors. You just got to kind of look at it and figure out, what am I doing wrong? Okay, so now we're getting down to um, uh, some methods that let you pull data up from, and this loc and iloc work with both um, series and data frames. So kind of what you're getting at here with these series will play into the data frame. But I'm going to go ahead, guys. I'm going to go ahead and put us on break and pause recording um, until 30 past the hour. Any questions on where we're at so far? And we'll have some lab time on Thursday to go through goofing around with data frames. Okay, no questions. I'll pause recording, and we'll take a break till 30 minutes after. Minimally sufficient pandas. Back to recording and sharing. The sharing of the screen, not the airing of grievances. Okay, so when we left, you can get to a series based on if you assign it an index, you can do that. But if you don't, you can get to it using the index value. But there's these functions that make this stuff fairly easy also. And with this, you can use slicing. You can do a single row or more than one row, a single column, more than one column, using loc, which is short for location, and iloc, which is short for integer location. And the difference being, loc uses the actual index value, iloc uses the integer location. So iloc 2 would be the third position. And we get into these more throughout our journey with pandas. But data.loc37 goes up here and finds we assigned the fourth element the index value of 37. So this one will return 3.0, and iloc index 2 is actually the third position, so that's going to return 2.75. So this is a method inside of the series class. So you say when it's a method of a class, you say the variable name, the object name, dot method. It's similar to the dot notation of a library, similar. It's how you get to something that's inside of something functionality wise. So iloc2 gets us, 2.75. There are lots of data series methods and Panda data frame methods like head and tail. And those are all methods that work on a given object. So like for example, we'll print the arithmetic average of our data we got what, four whole values here, 2.25, 25, 275, and 3. So that should be somewhere between 25 and 275, right? And then we'll round all of the elements in the series. We'll round them to one decimal point. So the 2.25 and 2.75 will be rounded down to one decimal point. Now it doesn't change anything. All that's doing is returning the rounded value. It's not changing the data in the series. That's always something you do with like an assignment statement, and then blank lines in between, and then we print the original series. So the mean, in between 2.5 and 2.75, the mean, arithmetic mean, is 2.625 that we got from this print statement, and then a blank line. And then we print the entire series rounded to one decimal point. So 2.75 rounds up to 2.8. So that's just an example of a method within the series class of objects, the pandas series objects. And then I printed it out to show you that it didn't change anything. The rounding function just displayed the result. It didn't actually change anything inside of the series. So we can subset a series using what looks a lot like the same Boolean expressions that you would put in an if then else. So let's see here. We have already worked with ways to subset our data based on index values or positions. But you very often don't know the position. Instead, you want to do conditional statement that evaluates to true or false for each row. It'll check. So we still use the square brackets just like you would with an index value, only you can put a conditional value in there. So this next cell goes out to this other CSV we have, exam scores. So I'll show you that one real quick while we're in the Jupyter navigator here. Where is that exam scores? There we go. It is.
Hey, Don. Hey, Don. Just a quick question.
Sure, go ahead.
On that last thing that you just ran, when it rounded all those numbers up, why did it not round 2.25 to 2.3?
I think because it's rounding to the nearest integer value. Oh, no, you're right. Why didn't it round it up to 2.3? Why does, let me think. So it rounded 2.25 down to 2.2, and it rounded 2.75 up to 2.8.
Right.
You got me. Anybody got a guess? Hunter, aren't you our math major? Anybody ever seen that movie Donald in Math Magic Land about Donald Duck? They used to show it to us when we were kids in elementary school. He's not too smart at math, nor is this Donald. Hunter, are you there? I don't know. Let's find out. So that was
Sorry, I'm curious.
Pandas series round not working. Pandas round is not working for a data frame. Round works on a single element, but not the data frame. Any ideas? I'm reading through the results here. Let's see what the this is saying that if it can be goofy if it's not the right data type. Did we check that? Yeah, it's float. It's float 64. Try to cast float type. It is floated. Dude, I don't know. Let me hang on just a minute. No, they are both 2 digits. Why did it round 2.25 down and 2.75 up? I don't know. I'll I mean that I would expect that would result in one of these questions on Stack Overflow of why the series isn't working. But that would be that's my first thing, is to Google it to see who else is having the same problems. And this is all on a data frame, not a particular series, but if it's busted on the entire data frame, I'm curious if we've got an active data frame, don't we? But does it have decimal values in it? I don't think it does. I'm gonna have to give that some research. Was that Dave or Jim?
It was Dave.
Dave. Good catch. Thanks for letting me know you're watching.
Well, I was just curious. I didn't
Yeah.
mean to hang us up on that.
Well, no, hey man, we got time. I don't know. I don't know if there. I would expect if it's rounding to 2.25 might go down to where'd it go? Hang on. Where were they? Where were they? 2.25 down to 2. Up to 8. Yeah, dude, it sure does not make sense to me. I'll have to look. Okay. So yeah, back to we've got another data file that is this stats exam 3 scores. And it's literally test scores from a stats exam. So it's a CSV, but you only have one column of data, and that's scores, and that's why we're able to read it into a series. So if you look in the Explorer view, you've got quite a bit of data, 382, so 381 elements for our series. So we're going to use the PD read CSV, and it's going to read it into a data frame. Exam scores will be a data frame because that's what read, even if there's only one column, but then we can extract that column and just deal with since it really only has that one column, then we can deal with it as a series. Okay, so we read the file, creates a data frame called exam scores, and then we make scores equal to exam scores, but just the scores column which is a series. And then I printed out the type of scores and the first 6 values. So the series has a head method that is the first 6 values, just like the data frame has a method that is the first 6 rows. So same method, just operates slightly differently between those two classes of objects. And it is, again, float 64. And there's your first 6 scores. Okay, display the scores series to see what data we loaded. And it's too many, so it will scroll. And then we're going to describe the series. Okay, because it's so many rows, Python automatically, the print function automatically puts in this ... so it doesn't just roll off your screen. If you accidentally printed 5,000 values, so it's smart enough to do that. And then this scores.describe, remember, is the statistical information. So there's 381 observations with an arithmetic mean of 113, standard deviation of 15 points. Somebody scored a 47, ouch, and somebody is a excellent student, scored a 150. But there's your mean, median, and first and second and fourth, third quartiles. Okay, so we can subset a series by using what looks like the same thing that you would put if then else. So this scores sub, and that's old school talk for subscripting for scores index values, scores greater than 145 will go through just like an if then else kind of thing, and if the score is more than 145, it will show just those values. So you get a limited subset of the data only if the score is more than 145. So it's yet another way to slice and dice data. It's not just the index value and the index the numeric location. So those 1, 2, 3, 4, 5, 6, 7 rows, elements, those 7 elements meet this Boolean, expression of having a score of greater than or equal to 145. So that's how you can start to subset your data. And what is actually happening in this statement? So first of all, we'll just print just the test. We're printing now. Scores greater than 145 is going to send something back to print, and we'll see that it actually generates. It goes through each one and tells you for each element in the series, it tells you if that element is greater than or equal to 145. So we get a list of 380 falses and trues. So that kind of shows you what is happening in this one, where it only returned those 7 values. There's only 7 trues when it goes through and looks at it all. So it's kind of creating a list of trues and falses next to the actual values, so that when you index by it, it says, if it's true, then give me the value, kind of sort of going through the 2 of those. So we'll do another one, all the scores below 90. So now we show, it doesn't say the number of rows. I'm sure there's a way to get that, but so yeah, 20 or however many scores that were less than 90. So I am absolutely sure at this point in the lesson, when I was taking this a few years ago, I raised my hand and asked Mike, where in the heck's the loop? It's looping through this series. It's doing a loop. And well, the loop is built in. If you look at the source code of these methods that appear to be operating on the entire list or the entire data frame, the method is looping through it. It's using a for loop to go through from start to finish, but you don't have to worry about that. It's built into the method. And they call that, many of these methods are vectorized, where it automatically they work on the entire data structure, on the entire list or data frame. The loop is built into the method. Okay, so that's a series. It's a smart list that you can get to by integer position, by index name, and you can subset with Boolean conditions. You can slice it just like you can a string, where you give it the initial value and ending value and a step value. So it's a smart column, a smart list. Okay, so now the data frame is one or more series or columns. And down here, we very rarely do this. I mean, in all the goofing around I do with Python, I'm almost always creating a data frame, either with a SQL query or opening a CSV or an Excel file. But this gets you, it shows you the syntax that there is a method to create a data frame from a dictionary. And remember, a dictionary is, key value pairs. So so now we have these key value pairs where we have 4 values for each of our fields. And when you run that in through the data frame method, it'll create what you would think a data frame with these 4 columns and these values for each column. And it puts it in a data frame called Pythons, like the actors, people in the cast of Monty Python. So we'll run that. And again, we get, name, office, age, and favorite, just like you would think, because they're the key values in the dictionary. In that order. And it also automatically assigned the numeric index location to each row, because we did not specify an index value. So it automatically has to have some way to keep these rows of data synced up, so that the name at index location 2 Graham stays linked up with the office of 305G. So that's how it does it. It assigns this index value to each row and kind of manages it like a matrix. Okay, what part of this table is the actual data? So we got an individual. We got a numeric index by default, but if we use this optional index equals inside of our data frame call, instead of just treating this name field as yet just another column, it'll now become our index. And it does print out differently. See, when we print it, we get a less visually pleasing output than when we just say Pythons. So Python really does treat those two things differently. And you just got to work with it to figure out which one suits your needs better. But now we can see on the left-hand side here, instead of having the 0, 1, 2, and 3, we have assigned the name as the index. It's not a column called name anymore. It's now the index to the data frame. So now if we want to print, the DF sub Michael, well, we'll do that here in just a minute. So we can, what part of this data is the actual data is the age, favorite, and office column. That's now the value, the actual table data. We no longer have a name column. Okay, we can subset the data by selecting a single column, and by rows, where you can kind of slice. This attribute reduction isn't a term I use in conversation, but you all understand what that's talking about, right? You can you could read a CSV and it's got 400 columns, but you really only like in Excel, you would go through and you would probably delete a bunch of junk columns that you don't need, so that you're not looking at so much screen clutter. Well, you can do the same thing with a data frame in one line of code, where you really just refer to the column that you want, or you can create another data frame and just say, just give me these 3 or 4 columns, and throw away the old big bulky data frame and just use the one whose attributes have been reduced. Or you can do it on both. And then I've written, double for loop that loops across columns and down rows, and based on where you are in each cell. So anyway, it's kind of like you'd think. A programming language can do anything that you want. But we'll look at the easy thing first. So we just want to see the column, the age column, which is a series, right? It's just a series of data. But the Python's command does go ahead and show you the index for that age. So the actual data is this 59, 66, 70, 72. But it does show you the index for those values, which is Michael, John, Graham, and Eric. Okay, and then similarly, we can look at just the favorites. And I guess this is the favorite Monty Python skit that these guys were in. I've seen a few of these. I know I've seen the Ministry of Silly Walks. My favorite skit is the dead parrot. I'd like to return this parrot. That's a good one. Good old one. Anybody else remember that one?
It's dead.
It's dead. It's no longer with us. No, it's not. It's only stunned.
Yes.
I don't know. And then to me, I didn't watch a whole lot of Monty Python, the TV show, so much. I watched Meaning of Life probably 15 times, and Holy Grail maybe 2 or 3 times. But I didn't watch the TV show all that much. Although there's some great skits in bite-sized chunks. I don't know that I'd ever want to watch. I don't know, a half an hour of Monty Python at a time. All right, so that's how you get to a column. And I just want to try something right here. I'm going to go off script because I'm feeling adventurous. It seems like you can do this. And you got it. It's case sensitive. Don't goof that up. No, bam. I know you can do this, but I'm doing something wrong. I'm doing something wrong. So there you go. I'd have to Google it. I think I got this in the lesson plan coming up anyway. Maybe you got to slice it. I know you can slice it from column 0 to column 1. Anyway, yeah, I'm getting off script, screwing around. That's how I learned, guys. I spent, I don't know, 3 or 4 hours goofing around with pandas again, getting ready for this week. Just trying different stuff out. Okay, so we can create a new data frame, and if you're creating a variable that is a data frame, it's pretty good convention to call it whatever is meaningful underscore data frame, so that you remember it is a data frame. Not all of our examples, Mike didn't follow that in all the examples, but I think it's a good idea. So we can create a new data frame that is just the location series. Like I said, if you want to, but it's going to bug me. Maybe next break I'll look at it. I know you can refer to specific columns in a data frame. I must have done something wrong with the list syntax. Okay, so yeah, all we got was the location, and head gives you the first 5 values in the location data frame. So what data type is the location data frame? I believe we're going to find out that it's a Panda series. There you go. Selecting, here we go, multiple columns. The old double square bracket. Oh, that's right. This gets me every time. And as you just saw when I went off script, it got me before. If you want to refer to multiple columns and kind of extract columns out of a data frame, you don't just use one set of brackets, because the outer set of these square brackets here, and like I said, you'll never remember this. I never do, but this is how it works. So the 14th time you see this, maybe it'll sink in. I've only seen it 13 times. The original indexing syntax requires the square brackets, right? Even if you're only going to do one value, you put the square brackets. So if you're going to give it a list, you need the square brackets of a list inside of the square brackets of the indexing parameter. And I know that sounds complicated. I don't know any better way to describe it. But whenever you're doing multiple things in a data frame here, you'll see this double square bracket whenever you're dealing with multiple columns, and it just takes a little bit of time to get used to. So this is how we display the first 5 rows of just these 3 types, because we've got in our data frame, we've got how many? We're back to DF, which is created from our DF way back, because we've been dealing with Pythons and way back, and we've been dealing with scores and series. And wasn't it created from like the Applewood? Way back. Yes. DF was created way back here with age, profit, location, vehicle type, and previous. So 1, 2, 3, 4, 5 columns. And if I'd wanted to, if I'd have been smarter, instead of scrolling all over the place, because I know it gets fuzzy on your screen. Let me get back to where we were, I can say insert above, and I can say df dot head. I can run just that cell, and that would have told me all of the columns that were in my data frame. DF.head is just the really quick way of doing that. I just wanted to remember where we declared that thing. Yeah, we declared DF 4 days ago and 10 pages up the screen. So now we've got 5 columns, right? But we're only going to display 3 of those columns because we've passed a list of just those column names. And the .head method says, just give me 5 rows. So that's now we're subsetting by multiple columns. Okay, but we can also, you can also subset by columns and rows, but extract profit, just profit, and location from the original data frame. So that's what that does. This DF with the double brackets pulls out just the profit and location columns or series and save the result in a new object named sub1df. So you got to have an assignment statement, right, to save it in another object. So sub1df equals just the profit and location columns of our original DF. And then we will print our new data frame with the tail. We'll use the tail method and the last 8 rows just to be jazzy. So there's the last 8 rows of our new data frame. Okay. Now selecting specific rows. So there's 2 ways to go at it. Loc pulls it based on the row label, or like if like we said when we used name in that one data frame to be the new index, or the label is another word for that. iLoc integer location, and that's the only way I can sort of keep these apart in my head. Integer location select rows based on the number. So we've got these methods that you call of a data frame using one of 2 methods. Loc is just or it uses the actual label that you gave it. iLoc returns the row index, and they are often the same if you're using a numeric. If you just use the default, they're the same. So it's not as important. So Loc really only comes into play if you've assigned a meaningful primary key, whatever you want to call it, for that data frame. See the numbers to the left of the data in the results of the previous cell. Here we go. Talking about this print stuff here now. In this case, they represent both the index and label of each row. Pandas automatically assigns an integer. Yes, it automatically creates that integer index if you don't tell it. Like most programming languages, Python uses zero-based indexing. Yes, so it starts at 0. We've seen that many times before. So select the first row of the data frame with this label, and to select multiple, you provide a list. So let's insert a cell above. Not sure why I didn't have that before, but let's just do this line of code above there, df.loc 0. And it automatically plugs in that second bracket for me. So there we go. You get the columns at position 0. So now, in order to get multiple rows, we use the loc method and a list of index values. So we got to that's where you start seeing that double bracket thing. And there you go. So we get 0, 89, and 177 because we passed it just those row values using the loc method. And because it's the same, it would work the same with iloc with this one. Let's modify that. Yep. But we'll see here in a minute where if we're using a meaningful index, we go at a slightly different way. Everybody doing okay? Are these executing all right?
So far, so good.
I thought I error checked this notebook. I think you're working with the exact same notebook I am. Okay, so now you can subset rows and columns, and this is where I was telling you I had a nested for loop when I was working with the Waco Media data, where I used one for loop in this first position and the next nested for loop in this position. So I was looping a row at a time, and then inside of that I was going across each column. So you had to use two for loops, one that chunk down each row, and then one that clack across each column. So that's how you do it, is in the loc method. You use two arguments. One first is the row and then the column. Okay. How do we decide between loc and iloc? Well, integer location is when you're going through sequentially. Loc is when you've actually got a value that you can go and look up based on that value. So run the following cell to see how it works. So this is, let's see, specify the first 15th. Yeah, 0, 14, 42nd, 114th. Yep. So specify these rows and only these columns. And then you've got the outer bracket on here. So within the loc brackets, these outer brackets are what you need minimum for the loc method. Now we're passing it two lists, really, one being the column index and the other being the column indexes, which are really the names of the columns. So there you go. And depending on what you're doing, you can construct all this stuff, and like I said, there are institutions that use Python data frames for all of their data engineering, and they go through it using all this different logic and whatnot to create what they need. So that's the syntax for pulling out specific rows and columns within a data frame. But I want to see something here real quick. I'm going to add because I'm morbidly curious. No, we're up at break time again. All right. Let's pause it one more time, and I think I can get through. Yeah, I'll get through this notebook. I think. Yes, I will get through this notebook, even if I have to talk fast and stop telling interesting stories. I know you're like, no, don't stop telling interesting stories. That's what makes this class worthwhile. And I'm like, hey, sometimes, you got to set aside the interesting stories at the cost of, entertainment for information. All right, guys. 30 minutes past the hour. We'll come back and we'll finish slicing and dicing these data frames with pandas. Okay. Resume recording. All right. So yeah, as I've been intimating, we can slice rows and columns. So if you want um, a subset of rows or columns, um, you can use that slicing, that number colon number, just like we do with string slicing. Um, a lot like the range function, where you give it a start and an end. But remember, it's left inclusive and right exclusive. So it's starting from the first one, but all but the second number, up to but not including the second number, right exclusive. Yeah, I don't know. I do not know. So when you want to specify row or column names, you use loc. Oop. So re-execute that. Whoop. Control enter. There we go. Yeah, when you want to when you have a name for the index, you use loc. When it's a position number, you use integer location. That's the only way I can remember it is position number. You need the I loc, not the loc. So the generic syntax for like integer location is to use the first row and then up to but not including row end with the colon in between. So start colon end, and then column start colon column end. So it goes rows and columns. And you can do both, the first 10 rows and column, 2 through 5, whatever the case may be, to subset your data frame. And like I said, a lot of times that's really useful when you're creating another data frame that is limited. And remember, the end value is the first one to not appear. So it's up to but not including the second value because it's right exclusive. And these negative numbers do start to goof around with you because it goes like to the end and then backwards. So those can be really confusing. But first, we'll look at our data frame, our first 10 rows. And again, you use round brackets here because the head is a method and round parentheses are how you send a parameter to a method. So I know that can get confusing when you're looking at iloc and it uses square brackets, but it uses index format, which is the square brackets. So it's just the way it goes. So we can extract the desired rows. We're going to pull integer position 3 up to but not including 8. So 3, 4, 5, 6, and 7. So I'm expecting to see 5 rows. And since we omitted the column argument in the iloc call, we're going to have all columns. So extract the desired rows. So from 3, up to but not including 8. That's why we got 3 through 7. Okay. So yeah, when we're using meaningful column names, we got these nice meaningful column names. Why would you not use the column name? So here we'll grab rows. Remember, the row is the first argument, but we're going to use the loc method this time, not iloc. But we use the same since rows don't really have a name for them. In this data frame, we're going to use 3844, and then the next argument is a list of column names, so they've got to be in square brackets. If you didn't have these square brackets, it would be looking at these column names as individual parameters, which would violate the syntax. So there we are. We're actually passing it to lists, really. Lists of values. 38 to 44 resolves to being a list of numbers. Okay, so we'll pull out just 2 columns and just 7 rows of data. Why is it lying to me? We start at 38. Oh, because we're using loc, not iloc. See, is that bugging anybody else?
I was curious.
Are you talking about why it's including row 44? Or?
Yeah. Why is loc including 44, whereas iloc excluded was right exclusive?
Yes, that's was going to be my question.
Yeah, I would have to. I'd have to pull up the documentation because he didn't address that. Mike didn't address that above, did he? iloc is right exclusive. But right inclusive when using loc. Yep. Yeah, that was that state. Python is left inclusive, right exclusive when using ranges, numeric ranges in the iloc, but it's right inclusive when using loc. Yeah, just another nuance that and there's Captain Obvious. Yes, it's confusing. So loc is right inclusive. And you kind of expect that because you're sort of using labels, just like you would, I mean, like this, when you're using these column names, it's not right exclusive. It's not everything between vehicle type and profit. It's everything in the list. So that kind of goes back to making it operate more like you would expect it to. So that's how the loc function works. Okay. So here's some more slicing exercise. So Python's was just our age, favorite, and office. And our index is their names. The data is the age, favorite, and office. So Python's from Eric to Eric should just get us the Eric row. Yes. So we just get the row where it's equal to Eric. Michael to John should get us 2 rows of data, Michael to John. And if we change that to Michael to Graham, say, we'd get those 3 rows. And if we changed it from John to Graham, again, we'd get just those 2 rows, or what's in between those 2 rows. And if we did it from John to Eric, yeah, we get what's between start and end of those rows based on just the index value. So there's, yeah, multiple ways to go at it. So Boolean conditions within a data frame, just like with the series where we can limit and we kind of go through and check each row and only show the ones that meet a condition. You can do the same thing, but you can check the condition of a value in a particular column. So the Python's just wants to show everything in the data frame, but this statement in here says it only show me the rows where the age column in the Python's data frame is greater than 67, which should just be Graham and Eric, right? So that should just show us Graham and Eric. Graham and Eric. There you go. Okay, so let's do another example with our larger data set. Applewood 2011 CSV. That's what, 380 rows or whatever. And we'll call it cars. So in this next one, we're going to create and again, we're violating our naming convention here. Cars underscore DF would be better practice. So we're going to read the Applewood file into cars and then describe it. So we get 180 rows. And we get 3 numeric fields that the describe method goes into. Cars.head would be your more conventional look at the first 5 rows and all the columns, but without giving you any information about data types or anything like that. Okay, so if we wanted to create another data frame, sub cars, if we're assigning making an assignment statement, it's going to see that this is a data frame data type, so it's going to make this one a data frame too. So subcars equals the cars data frame, but the slicing value we're going to give it is cars where the age column has a value of greater than 67. And then, of course, subcars will just print out basically our dot head method. So actually, let's do that. I don't like that. I don't like not knowing. Let's do dot head. Yeah, just so it just limits it to that. Yeah, because there's 6 rows in it. So that's how you create a data frame based on a subset of rows. You could, let's say you wanted to do something different. Let's go off script just a little bit. 12:43, another half an hour. I got that many cells. Yeah, no problem. So what if we wanted to filter our data like you would in Excel, and we only want like certain types of cars in our data set? So we'll add a column here. Let me, I'm gonna say cars dot head, give me 20 rows just to see what we got here. Okay, sedan, SUV, compact, sedan, and there's another method. I want to say it's value counts. I think we get into it here in a minute. If I wanted to, I think value count ounce. I think. Yes. It shows you the various value counts in each column, but I'm getting ahead of myself. So let's say I want to do this up here and create another data frame. I'll cut and paste that code down here, but I want to create subcars too, and I want to say it's cars where vehicle type dash type equals, and remember the assignment equals is 1 equals, the check equals is 2 equals. So I want a new data frame, but I want all the cars where vehicle type equals not 67. Almost hit return on that one. Where vehicle type equals, let's get all the SUVs. Let's see how that worked. Oop, now I gotta add another one. And we got to do sub cars 2 dot head, and we'll say 20. And if you pass more than there is in the data frame, it'll just give them all to you. So here are all the SUVs. I think that's all of them. 65 is the highest. Nope. Still not all of them. Wow, a lot of SUVs in there. And I'm sure I could Google it. There's a way to count those unique values. I think I got it ahead of here. Anyway, so there's any number of Boolean expressions that you can put in here to subset a data frame. And like I said, very often you want to do that so that you are, when you're creating another data frame that is a limited segment of the data, either limited by rows or limited by columns. Okay. And I will cut those out of here so they don't jump out at me next time out of the blue. And there you go. Oh, yeah, I had it in the next cell. Yeah, where the location is Olene. I just went through that exercise for nothing. Blinding flash of the obvious. Okay, and rows, yeah, this is the same exact exercise, only looking at a different column. This is where previous is if they've made a previous purchase. Okay, and you can add a row by using a method that appends a new, as long as the row is correct, it won't error. So we can create a data frame that is really just one row of data. So there's only one row in this data frame. We're going to call that new row. And then if you can append data frames, 1 row, 20 rows, 2000 rows, as long as they're in the same structure, by using this Python append method. So Pythons equals pythons.append, and then you pass it the name of the data frame you want to append to Pythons. And there we go with that. So we've added the Terry row. Looks just like part of the original data frame. And sometimes you might want to add a column of information. So you need a series that is the same number of rows as you have in the data frame. So since we have 1, 2, 3, 4, 5, now we need a series of 5 values if we're going to add another column. So new data equals, and we're going to use the series method this time, not the data frame method, because we're only creating a series of these 5 values. So we pass it a list of values, and we specify the index equals this list of index values. And regardless of the order that they're in, it'll line up Graham to 10.5, John to 12, Terry to 10, the order that you put them in your series call there. So let's see what we got with new data. Graham 10.5, John to 12. See, even though it's not necessarily in the right order, and when you go to add it, because of you got these index values, let's look at Pythons. Remember, Pythons is in the order Michael, John, Graham, Eric, Terry, and our new series is in the physical order Graham, John, Terry, Eric, Michael. So they're out of order, right? But since they're indexes, when you go to add the column, it uses the index values to line them up appropriately, which is kind of automatically. So you create a new column by calling out just like the column name, kind of like you would, it's a new column name, So it looks kind of like when you declare a new variable. So Python's.shoe size is going to be, even though we didn't really know what, 10.5 and 12 and 10 and 9.5 were, we're going to give it a meaningful name of shoe size. And then we say that the Python shoe size column, which is just a series, right, equals new data, which is a Panda series. So that's how we add a column onto a data frame, just like you could create a calculated column in Excel, or read in, cut and paste a new column. If you were doing like, United States data and you had all 50 states and you went out and found a column of, average high temperatures or whatever, you could cut and paste those 50 values right into your Excel spreadsheet. You can do the exact same thing in Python. Again, interactively. I don't know that this would ever be faster than Excel, but it does, as Paul said, it does the boring stuff quickly and accurately time and time again. Okay. So there's our new column out on the right-hand side. And you'll notice that like Michael's shoe size is correct. John is 12.0. All the shoe sizes line up correctly, even though it was all in a different order, because we had an index value, which makes it smarter than a simple cut and paste of columns like in Excel. So there you go. And we can drop a column by using a method called drop. It's nice when they make things make sense like that. But now I don't know why, but you need axis equal 1 to specify that it is a column rather than a row. You can drop rows as well, but you need this axis equal 1 to tell it that it's a column. I think the default is axis equals 0, which is actually a row, but don't quote me on that until we're actually using it in action. So there you go. So I'm going to drop the column shoe size that we had put in there. Or am I? If we display Pythons again, what happened? It's still there, because we have talked about in place equal true, right? Somebody confirm I'm not crazy. We have mentioned the fact that Python doesn't really make the change unless you put the in place equals true operator on there. Nobody remembers that?
My knowledge.
Could have swore we talked about that before. So anyway, it's a fail-safe. I apologize if I have not mentioned it. There's a fail-safe in a lot of these methods where you do the action, but it's temporary. It's only yeah, it's temporary. It doesn't actually affect the object unless you say in place equals true, and then it overwrites at that memory location. So this Python's.drop is really just a display of this line of code here. Is really only displaying the data frame if we were to drop shoe size. It's not actually dropping shoe size unless we say in place equals true. So let's see what happens here if I don't use the in place operator and I do an assignment statement. And that, so I'm creating another data frame based on Pythons, but I'm dropping the shoe size axis equal 1. I'm trying to remember why I put this in here. I put this in here late last night. Yeah, you don't need the in place equal true if you do an assignment operator. That's what it is. Up here, we're not assigning it, right? We're just saying pythons.drop. So that's what that does. But the command, unless you add the in place equals true, it doesn't actually do it to the Python's data frame. That's when you need it. Like I said, if you're creating another data frame in an assignment statement, it takes the results of this drop command and makes it so that Python's 2 now has dropped that shoe size column. And that's the way that works. Okay. Drop location and previous from the Applewood data frame. So that won't actually drop it. The way we've got it right now, it displays it, but it doesn't actually drop it. Because if we do another 20 minutes left, if we do another cell here and we say cars.head, pretty sure, yeah, location and previous are still there. But if we use this line of code and we say cars.drop location previous in place equals true inside of the pure cars.drop statement, in place equal true will make it so. And again, this is, I mean, if you're working with Python, this is important stuff, but if you're rarely seeing it, it can be hard to remember all this. So don't sweat it. But there you go. So that if you when you're working with a data frame and doing that data engineering, that explains why your changes aren't actually taking place. It's because you don't have the in place equal true to make this method call actually overwrite the memory location cars with the change. Okay, a little more about data files. So we can, here's where I talked about the temp directory this morning, the TMP directory. So that's once you go through all this these machinations to pull up a data file, and then you can create calculated columns, you can subset based on a column equaling something. You can then, once you have it all the same, like like we had location up here. Where was location? Yeah. Once we create this data frame, you could then drop column location, right? If you were squeezing down this data in a program, wrangling data so that you're taking kind of a large semi-useful data file, CSV file, an Excel file, with it's got rows you don't need, it's got columns you don't need, it's got maybe you need a calculated column or two to convert numbers or something like that. You do all this data wrangling, and now you have this data frame in your Python program, but it goes away as soon as you exit the program, unless you write it out. So these last cells here show you how you save a data frame back out to CSV. So in my TMP directory, I'm going to go make sure I do not have cars_df anymore. We can close that out. Don't need that anymore. So if I go up to my Python directory and down to my temp directory, I do not have a cars data frame anything in my TMP directory. So if I go over here back to my notebook, I'm going to call the toCSV method, which writes a data frame out to disk and saves it, of course, in a CSV file. So I've said with my R here, just like every other file handling thing I do, treat slashes not as special characters, but as actual folder names. So go up one directory, go down into temp, and write out my cars data frame to cars d_df.csv. And then I hit whack on that. And now I go back to my Explorer and poof, I have cars_df.csv. And because I don't have an assigned index column, the index name is blank, but then I've got the 0, 1, 2, 3, 4, 5 for each row. And then I've got the meat of my data frame in here in age, profit, and vehicle type, because we dropped location and previous. So that's how you save the results of all of this cranking. So save the data frame without row indexes. Yeah, this is kind of goofy, right? Because I wasn't using a meaningful column name or a meaningful name in my data frame. I got this blank first column name in my CSV, and then I've got these index names that I really don't need. So the way to avoid that is by saying don't write the index when you're saving it out. So if we go look at cars_df2, we put that away. Well, I'll leave it up. Cars_df2, we have saved it out now with just the meaningful columns and the meaningful data. So we've gotten rid of that artificial index that Python assigns to a data frame by default. Okay, so that's a whirlwind tour of Pandas data frames. You can work with Excel files the same way. On Thursday, I want to show you how a database query works. There's more than one way to get tabular, good old-fashioned worksheet looking data into a data frame, and then do some lab time reading in a CSV and dropping a column here and there. I've got a notebook that is common data wrangling stuff, but I need to go through and make sure I error check it. That we'll do on Thursday. So we're in the wrangling data, but doing some analysis. I mean, you're finding all the descriptive statistics and whatnot. But there's just any number of things you can do with this Pandas. Well, here, while we got a few more minutes. In this last, here's just talking about Excel files. If you're ever gonna use Excel, it's a little trickier. It's kind of in between the trickiness of a CSV, which is as straightforward as it gets, and working with a database, which is, I think, pretty tricky. It's just got a few nuances that are things to take into consideration and learn if you're going to be working directly with an RDBMS. But down here, we got cars as a database, or cars as a DF. Yeah, like there's I want to say there's a correlation matrix. Yeah, like there's all these cool analytical methods within the Pandas library. So we've got this cars data frame. There's a method called correlation that goes in to a data frame and correlates automatically all of the numeric columns, just like how Describe went in and gave you the descriptive statistics, but only of numeric columns. This correlation method, just poof like that, gives you, if we had 30 columns that were of numeric data, it would correlate each one. And this is it's kind of a little confusing because there's only two here, but age is 1.0 correlated with age in this top left corner, and profit is correlated with a score of 1. This is R squared, by the way. But you can see now that age and profit, if you go to the intersection of age and profit, they're correlated with an R squared value of 0.26, which is loosely correlated. I think 0.5 is where you start seeing correlation that's worth paying attention to. Oh, so there you go, guys. That's your pandas library. That's the about about pandas and working with tabular data in there. So what that just shows like the basic syntax of getting tabular data and then looking at particular rows, either the first 10, the first 20, the last 10, the last 20, rows where a column is only equal something, rows that are between like row number 20 and number 80. So however you want to slice and dice that. And then we can also look at just columns within there. We can reduce by columns by specifying the names or the column position if you've got a super wide CSV file. And then you can even start to link data frames by that index value. Yeah. So you could go look up something kind of like we join tables in SQL. You can join data frames by that index value. So it like I said, this is just the beginning. It's kind of hard to show any more application unless we get things a little bit more complicated. So any questions or comments? How am I doing here, guys?
All good to me.
Sounds good. Okay, well, I
Just
will. Like I
have
said,
one question real quick.
go ahead, Jim.
On the CSV files, I'm getting errors when I run this, and I'm not seeing what I'm doing differently. It could just be that I didn't open something earlier in the notebook.
Could be. Hang on a sec. We got time for this here.
I think it's a file. Oh, I think it's the address. It says TMP cars.
Share your screen, Jim, if you don't mind.
Yeah, sure. Hold on just a second. Sorry. Good Lord. Yeah, right there, the big green thing, silly. Stop. That's the wrong screen.
Whoop.
That one. Can you see that?
Yeah, that's the one you had it on before.
Okay.
Okay.
Is it just is it the address here?
It may. Did you go out using File Explorer and create that temp directory?
I don't think I did.
I think that may be the error. So
Okay.
scroll down a little bit.
File not found error.
File not found error. So yeah, I'm betting that's what happened. So try it. Go use your File Explorer down there, your normal Windows thing, and create a folder called TMP that is at the exact same access as your notebook directory. You know what I mean? You need a TMP directory like at the same level as your notebook and your
right here.
Right there. Yeah, right click on that big section over there and say new folder.
Yep, I see. I knew there was something silly I did.
Yeah, that's. I was wondering. That's what I said at the beginning of the thing. I have it, but it does not go created if you don't have it. It creates the file if the file's not there, but it'll barf if it doesn't see the notebook. So now go back to the notebook. It was just lowercase TMP, right? Yeah. Try it again.
Yep.
So
Okay, hold on. I think
I was going to say, go back to your Explorer up there. Yeah. Yeah. Go back to the other
Yeah.
tab, the Notebook Explorer. Well, you can do that, but it's not as.
Yeah.
There they are. Yeah.
All right.
There you go.
There they are. They're there.
Yeah. So there you go. Experiment successful. Python does not
Yay.
have permission to create a folder. It only has permission to
Just a
create a
file.
file within the folder.
Okay.
There you go.
Well, that makes sense. I was thinking that's what it was, but I wanted to make sure.
No, I'm
All
glad
right.
I'm glad you're running it. Thank you for
Great.
having
Thank
a
you.
problem. All
Oh, I
right.
have lots of them.
There you
Don't
go.
thank me for that. Don't encourage me.
You know, I'm gonna stop record because I'm all done for the any other questions while we're okay.